In the last episode, we answered why Databricks exists, why Databricks is so important in current data world. We also talked about the Spark. Spark was behind the scene actor of the Databricks, right? In this episode, we'll be answering how much we need to know about the Spark. All right, we will be deep diving about driver, executor, cluster, etc. This can be overwhelming at the beginning, but I'll try to cover this in the simplest way that I can. Uh, I also try to compare the Databricks with the SQL execution plan as well. I'm sharing my screen. This is what Databricks um, Studio look like. So we don't need to install anything. It's always do www.databricks.com, and this is all we need. And in this page, in left-hand side, there's workspace. We'll deep dive where workspace is the space where we play around all the notebooks and things like that, right? And there is a recent tab. There's a catalog. Catalog is like a database where all those table views, store procedure will stay. Those code will stay right there. And the jobs where we can schedule those note to run on some frequencies. So job and pipeline will schedule here. Compute is the computer, is a Spark behind the scene, behind the hero. That's the compute right here. Similarly, there's a marketplace, right? Things like that. On top, there is this source menu where we can sort the notebook, table, jobs, dashboard, etc. We can directly source from here. And then also there is the setting tab where we can do multiple setting like compute setting, other security stuff change. Similarly, one important stuff that we can link these Databricks into GitLab repository from here. So those are the setting. And when we talk about the architecture, high-level architecture, let me go here. So we just see how these workspaces look like, right? And but behind the scene, there will be the Spark engine. When you write the code, asks to execute something, the workspaces will give an order to the Spark engine, and the Spark engine will have the driver and executor. And those driver and executor will perform this work and display the result to the workspace for us. However, and there in a Spark engine that doesn't actually store the data itself. So for data storage, we have to link, separate storage. Like in cloud storage, there's LDLS for Azure if you want to use Azure database, or if you want to use AWS, there is S3 bucket and things like that, or many more. So these three are the separate thing work together, make Databricks smart. So the same architecture I have designed, or I have rewrite in my way, just like this. So in Databricks again, on left-hand side in menu, we'll have the workspace, catalog, compute, jobs, and etc. In upper corner, there is the source box and setting box that we can do multiple setting. And middle, there is where we can write our code like SSMS. We'll be doing through the notebook where we write the codes, SQL code, ETL pipeline, everything. And then we can run this code from here. We see the result. We can see the result through the chart or graph as well from here. We can make it in the same Databricks place where data engineer, analytics, or other people can come and play around. This is one place steps up basically. But when we write the code into this notebook on a workspace, actually what it does is it doesn't execute by himself, but it asks to execute those code through the cluster. Cluster is computer, right? We talk about the Spark, right? So this is actually Spark. So this is a Spark. The Spark will have a driver and workers. The driver is basically will deep dive a little bit in in a little bit, but this is a computer where driver and worker exist. Based on what we give, what we order, what you ask to do it. Based on that, it will generate the cost as well. So that's the compute. That's a separate thing. And so similarly, as I mentioned earlier, compute doesn't store the data by itself. So to store the data, it should have the storage, separate storage, where all the table files will store. So again, it is stored in table file actual data in separate storage that we need to link to the Databricks. So whenever you see the Databricks is basically three things. Again, this visual diagram, there's a cluster, which is Spark, and then storage. Those three things is main thing for the Databricks architecture. They work together very nicely. Let's deep dive into a cluster itself. What is cluster? Let's understand a little bit more about this cluster. I'm gonna explain this cluster like a SQL perspective. All right, let me go. When you say the cluster is distributed computing. For example, there is a very nice example I have seen out there. So if you want to make something like 2,000 puris, right? Puris is something like food. So if you want to make 2,000 puris, and if you want to hire one chef, he probably need to spend 4 hours or 5 hours of his time to make those puris. However, the same time, if you hire 4 or 5 different chefs, you can get the same amount of puri within 1 hour or less than that. So this is what the distributed computing is. So distributed computing again is you can distribute your work in multiple workers, right? So you can get the same result with in a short period of time. We can think about Spark as a SQL execution plan as well. So I have written left-hand side as SQL, and also we have created the similar activity for the Spark. Again, in left, this is a SQL model versus in right, this is a Spark model. In SQL model, when you write the code, we write the query, we write the code, and it will create the execution plan, or it will optimize the query and create the execution plan. It operates through the CPU or core or computers, right? So query will run optimize through the execution plan and proceed through the CPU. Same thing, almost same structure will happen in Spark as well. We write the code in a Spark engine. It creates the DAG. Instead of execution plan, there is something called the DAG, DAG in a Spark. We need to remember this word like DAG. DAG is like simply a distributed execution plan. So this DAG is just simply distributed execution plan. So it will distribute your work into multiple executors and give the result. This is how it works, right? Like the previous example, if you wanted 200 puri, that will to the cluster or Spark, it will give multiple workers, appropriate worker, and perform that result in a smaller set of time. So again, if you understand the SQL execution plan, you already understand the Spark is conceptual level, right? So nothing fancy. Just remember DAG, which is simply a distributed execution plan. That is all the main difference between those two. Let's quickly jump with the drivers and executor. This is a really simple concept as well. So in this previous example, you can see that these chefs are executor. They execute. They produce the actual puris with a distributed system. But there is, if you want to hire one caterer, like whoever is like a manager of the chefs, she will be managing all these chefs. She will hire new chef. She will fire new chef. She will maintain. If one of the chefs is sick, she will give that work to the another chef, etc. So in this example, this caterer is a driver, and these actual chefs are executor. So whenever you say the driver and executor in Spark, we should understand this. We should remember this example. Like driver is a brain or coordinator. Driver is a brain or coordinator, and executor are workers or whoever who does that actual work. The driver understand the query. Drivers will understand the query. Driver build the execution plan or DAG, and then driver also coordinate with the worker. So three things will perform by this driver. So Spark driver will understand the query. Spark driver will create the execution plan. Spark driver will coordinate with the worker. For executor, the executor do the actual work. So think of that like in SQL Server execution plan as well. It's almost similar concept, right? And another quick item is we, as a engineer, we don't need to configure driver and executor. This driver will automatically handle this executor. That is the beauty of Databricks. If you just go through the Spark engine, you have to manually do this setup. You have to configure this setup, driver and executor setup. But whenever we use Databricks, we don't need to do this setup. Databricks to handle automatically. And in Databricks or Spark world, there is a terminology called a cluster. What is cluster? Cluster is basically nothing, but it's just the tools for driver and executor. Cluster can have a driver node and executor node. Basically, in this example, these are, like we mentioned, these two are the driver and executor, but the cluster is like it's a owner actually, or who wants to give the order, right? Who give the order. So he has more power over driver and executor. So this is a cluster. This person is like a cluster. He wants to give the order to make 2,000 puris, right? He can change those to 1,000, or he can change to 5,000. So that's the actual cluster. And Spark world, Databricks world, cluster can auto scale, cluster can auto terminate. We don't need to do manual things, anything for the cluster, which is a good thing. Let's quickly jump through the cost on Databricks. We'll have the separate video about the cost itself down the road, but in high level right now, how the cost is determined in Databricks is it's a cluster size, which is how much computer we need. The second is the runtime, how long the cluster need to run. And the third is the volume, how much data to proceed. So based on these three main stuff, the cost will determine. Again, how much compute we allocate, how much this worker we needed, basically. How long this worker need to do the work, right? How many data they need to proceed. Those are the main cost factor for Azure, Databricks world. In later video, we'll be talking about what is always on cluster versus a job cluster, what is oversized executor versus auto termination, what is inefficient query versus efficient queries, etc. That is specifically for the cost basis, and then to determine the cost, the architecture is the key. We are not going to do any indexing like a SQL in Databricks that helps the cost. However, to determine the cost, it is the architecture level of design that determine actual the cost. The last item I want to cover in this particular video is why Databricks is easier compared to Spark. So Databricks, again, Spark is not a managed platform. It's not auto scaling. It can have multiple things to monitor. However, Databricks is managed platform. It automatic. It's handle multiple things automatically. So we have the cost prediction and things like that. So Databricks is much more easier tools compared to Spark. For this example, again, if you want to come back to the same example, if you have an event and if you want to have one cluster by yourself, a caterer by yourself, if you want to have a photographer by yourself, if you want to talk to the decorator by yourself, instead versus you can have the event planner. So this event planner is actually Databricks. Which this event planner is will talk with the caterer. Event planner will talk with the photographer. Event planner will talk with the decorator. Right? Instead of you handle everything like a Spark, you will be just doing a work with Databricks like event handler, and then this event handler like Databricks will perform everything for us. So this is the nice example that I found there about to understand the Spark and Databricks. Let's have a quick recap what we covered in this video. So again, Databricks manage everything around the Spark. Spark is a distributed managed instance, distributed engine. Drivers plan for work, executor do the work. Driver actually plan the work, executor actually do the work, and so on. So these are high-level architecture again about the Databricks. And the next episode will be move on from the architecture to a little bit hands-on on Databricks workspace, notebook, SQL, and Python, where it fit together. So we start doing some hands-on right here. With that being said, thank you for watching. Bye for now.